Hi Math 2B, this is Mr. Roberts. Today we're going to be completing the notes for section 6.1.4, how can I rewrite it? We began a conversation about what it means to have fractional exponents and what exactly that looks like. One of the things I really liked about this was this observation, Daniel wanting to understand why 9 to the 1/2 was the same as the square root of 9. And he's basically saying, she reasoned that 9 to the 1/2 is asking for one of the two repeated factors with a product of 9. So the two repeated factors for a product of 9 are 3 and 3. And if we have just one of the two, it would be a 3. And that works quite nicely for square roots. So that was our introduction yesterday. And we went all the way through to question 38, and that's where we stopped. So we're going to pick up our notes with question 38 in just a moment. But first of all, let's review the independent practice that you did yesterday in class. So on yesterday's question, we were given that for question 1, we were given the sine of theta was 3/5, and I went ahead and plugged in, if it was 3/5, that means that the opposite side is 3 and the hypotenuse is 5. When I see the 3 and the 5, I either identify it as a Pythagorean triple, or I could use the Pythagorean theorem to find that the other side is 4. At this point, because I know all three sides of this right triangle, I could find the cosine of theta, which is the adjacent leg divided by the hypotenuse 4/5, and the tangent, which is the opposite over the adjacent 3/4. So those are our answers for 1 yesterday. In number 2, we were asked to solve for x using the zero product property and factoring. I factored this without using a generic area model or a diamond problem. If you would like to use those, please feel free to do so, and if you need me to, I can continue to review to do that, but I think most of us are pretty comfortable at doing this. The two values of x we should get are 3/2 and 2/3. For question 3, we were given that the hypotenuse of a 30, 60, 90 right triangle was 12√3. And in order to go from the hypotenuse to the short leg, I had to divide by 2. So I took the 12 and divided by 2, and I got a 6√3. And then to go from the short leg to the long leg, we had to multiply by a √3. So you can see I'm taking the 6√3, and I multiplied it by another √3. √3 times √3 is 3. That's why this became 6 times 3, or 18. So my answers there yesterday were 18 and 6√3. For 4, we had a 45, 45, 90. We were told a leg was 3√2, and I found that the other leg would also have to be 3√2, because again we call this the half square, or the 45, 45, 90. So all the 4 of the legs, if we were to extend this and make it a square, right, all the legs would be 3√2. And then that hypotenuse, as we go from the leg to the hypotenuse, we multiply by √2. So I've got this 3√2, and I'm going to multiply that by another √2, which gives me 3 times the square root of 4, or 3 times 2, which is 6. And then second half of these after the notes yesterday, number 5, you can see the answers 3/5 and 4/5 are the answers reduced. Number 6, when I solved that for x, I ended up getting x was -6. For 7, x was the square root of 6, and y was 2√6. This was a little bit more, probably more tricky than I intended it to be, but I think it's a nice problem nonetheless. This is the long leg, and if I want to go from the long leg to the short leg, I have to divide by √3, and you can see I'm doing that. I've got the 3√2 divided by √3. One of the things I'm not showing here is how do I rationalize that. So I've got the 3√2 over √3, and I'm simply multiplying that by the square root of 3 over the square root of 3. My denominator then becomes the number 3, right? Root 3 times root 3 is 3. So I get 3 times the square root of 6 over 3, which is just simply root 6. And then, of course, as I go from the short leg to the hypotenuse, I doubled that. So that's why it became 2 root 6 for y. And finally on 8, it was a 45, 45, 90. We were told that one of the legs was 6, therefore the other leg, x, would have to be 6, and the hypotenuse would be 6 times the square root of 2. So let's move on and look at our 4 first questions for the day. Okay, so please have a piece of copy paper, fold it like we did yesterday into 4 sections. 4 questions in front, 4 in back. So the first 4 questions we're going to do today, this is the 30th of January. First question is, given the sine of theta is 5/13, please find the cosine of theta and the tangent of theta. And I'm going to provide a sketch today. So here's theta, and fill in the information you have and then use that to find both cosine and tangent. X squared plus 6 times x plus something equals -8. I would like for you to solve this today by completing the square. So you know that we're going to have to add something on both sides of, we need to add something on the left hand side to make the left hand side a perfect square. We then rewrite it as a perfect square trinomial, and then add the same thing over here, and then basically we take the square root of both sides. And you know what? I'm probably going to do this one with you, and after the lecture notes, I'll have you do 2 of these on your own for review. So if I wanted to complete the square here, because my coefficient for x squared is 1, I'm just looking at the 6, I'm taking half of that, I'm getting 3, and I'm going to add 9. So I'm going to add 9 to both sides. And when I'll just put a plus 9 here and a plus 9 here. So this left-hand side now is a perfect square trinomial. It is x plus 3 quantity squared. Nice to verify that, but I think you can remember the visualization and the discussions we've had about that. But that's x plus 3 quantity squared. And on the other side, it equals just the number 1. Now, if I take the square root of both sides, I get that x plus 3 equals plus or minus the square root of 1. And then simply, I'm going to subtract 3 from both sides. So x equals a -3 plus or minus root 1. Well, the square root of 1 is pretty straightforward. It's just the number 1. So x equals a -3 plus 1, and that's one value of x, and the other value of x would be -3 minus 1. So x is either -2 or -4. So these are our 2 values of x, and we obtain those by using the method of completing the square. And that's always nice. It's a nice method, especially if your leading coefficient is the number 1. It works rather well. Okay, so you did 1 and we did 2 together. Sorry. For question 3, you can see it here. And question 4, you might need to pause or rewind this video because I'm going to pause it right now.